no doubt was. All right, any questions?
It'd be about the lab that we're turning in today.
Sure.
I just had a question on the theoretical slope of the plotted trend line of the graph was angular speed squared versus tension. So first, that's just an equation, right? You just want us,
Right.
like a formula. So
Yeah.
there's no actual theoretical slope.
I'm pretty sure that's all that's supposed to be there. Based on equation 3, what is the formula with the theoretical
Okay.
slope?
And so for the formula, I feel like I did it wrong, but like that's with most stuff in physics, so like.
What'd you get for the?
I got like, well, I just put like angular speed squared over the force of tension, and then I like went in and said what exactly those break down into. Is that like?
So you came up with something way complicated?
Yeah, well, kind of. So I just had like slope equals this, which is like that, the graph.
I mean, ultimately, you should have an equation for slope equals some function of mass. So slope equals something with mass in it. It should be relatively simple.
Oh, okay, well, like, is this like the right starting point? Am I
Yeah, that usually works as long as there's no intercept theoretically. Ultimately, you want to get the form into y equals slope x plus b form. That's
Right.
ultimately what you're trying to do. So, since you're doing omega squared and tension, I would expect you have omega squared is equal to something times the tension plus 0 in our particular case.
Okay.
Now, there are occasions in which this is not supposed to be 0, but
Okay.
it's 0, I think, for most of what we do here. So, starting with equation 3, I believe it was, where I have tension is equal to m omega squared r.
Isn't it divided by?
Pardon?
Never mind. I thought it was divided by R, but I'm thinking about centrifugal.
Oh, if you did mv squared over r,
Yeah.
or m omega squared times r. So you would need to then, yeah, so you would need to be able to manipulate this.
Okay.
Now, the trouble with just doing a straight up divide by mr is you don't know what r is.
Right, R. Don't we though?
Actually, wait, mistake there. Because it's down at an angle like that,
Oh, right.
r is this distance, and that's L.
Oh, okay.
The centrifugal force is actually Ft, if that angle there is theta, Ft cosine theta is equal to m omega squared r.
Okay,
And you didn't measure the angle, I'm feeling pretty sure.
right.
But this was the starting point, and solve for omega squared somehow resolved this cosine theta bit,
Okay.
and the slope is whatever goes in there.
Okay.
So we wanted our omega squared on the y-axis.
Yes. Realize you get it backwards?
Yeah, I mean, I did it backwards, but somehow the mass that I ended up with in 6 was close to what we had. Like, so I had like a really low slope, but
Right, it should be the reciprocal of what you would have gotten ordinarily.
okay.
It ultimately comes down to what you have here. So if you had it backwards, so you had tension is equal to something times omega squared, then the slope should be equal to whatever times omega squared.
Okay, yeah, so I had tension equals the slope times omega squared.
Okay, and what was the slope equal to?
I had like 0.0166.
No, look, theoretically, what would be the formula for the slope?
Oh, that's the mass times radius.
Mass times what?
times the radius.
That would not be it. Because if I went, because there's this cosine theta right here, so if I'm using this radius, this would be mass times radius divided by cosine of theta, omega squared. You got two variables there. What do you use for radius?
The radius, I use, the length, which is the 0.6851.
So you use this distance, the hypotenuse, instead of
Well,
the actual
yeah.
radius of the circle.
So, I thought like since, like when we were spinning it, like, I didn't think that there would be much difference. Since it's like, I thought, I mean,
And the faster you spin it, the closer R and L are to each other, but the slower you spin it, it's gonna sag more, and there's more of a distinct difference. Now, you just happen to stumble upon a correct answer, but if you're gonna use length, then you need to have L in there and not R.
okay.
Now, you could try to bluff it and just go with, the other steps are so obvious, I didn't think I needed to write them down. Or if your graph is backwards, you could make the claim that, well, we spun it, tried to figure out what tension was needed. So tension was dependent upon the omega squared. Of course, you missed your opportunity to do that. The dependent, since how fast you spun it depended upon the tension in the string, how much weight you had hanging at the bottom. This is dependent upon that, so that's why this is the vertical axis,
Okay.
which might be an answer to one of the questions.
I'm still not sure how the mass that I ended up with from calculating it was like almost like exactly the same as what we measured. Like I had, so my
Genius.
my whole graph was backwards, but the mass was,
All right, first off, the video, did any of you watch the video where I went through the derivation? I did do the derivation in that, didn't I? Okay.
I think I should have seen more of it.
Yeah, I would recommend, I'll tell you what, I'm not gonna have these graded by Friday. I am handing stuff back today, by the way. But go watch the video. If you don't understand the video, then by all means ask, but please watch the video.
Are you saying we can turn them in on Friday?
Yeah. All right, other questions? And thanks for watching. Okay. I was taking a quick scan at chapter 6 to see what I've left off, and I haven't, we're done with 6. So the test, that covers the end. So you have the test a week from Friday. Wait a second, I do tests on Wednesdays. And now. So I'd much rather have the longer time period. So we have 3 options. One, we leave it where it is, and you have some faith that I can make the test shorter. I don't know how much faith I would have in myself, but you can gamble on that. We move it to a week from today, or move it to a week after. After. We'll do it for after.
I like it where it's at. Like, I know tests on Fridays are fun, but, well,
Right.
that cuts into your teaching time, so.
All right, so we've got the 3rd, the 5th, and the 10th. Be nice if we had a majority, but we'll see what happens. Move it to the Wednesday before. Keep it where it is. Wednesday after.
Am I allowed to vote twice? I'll vote for the next Wednesday too. I just don't want it on Friday.
Can I give my reasoning for why I went on the 10th?
Yeah.
I work really slow, so I need the extra time, and since, I won't be able to finish it on Friday, so I don't wanna.
You have extra time on Wednesday.
Then we'll, yeah, move it to the 10th. Yeah, that's gonna be better.
I guess that's the tiebreaker right there.
Okay.
If this is a hardship for anyone, just talk to me individually. Or the shift. At least I don't give 3.5 hour tests anymore.
Would that be like was that the original test one with A and B?
Yeah, well, in the first couple of years, that was pretty much my tests were marathons.
Gotcha.
It was not my intent. Whenever I wrote those tests, I always thought, this should take about an hour. One 10 test, those I managed to usually hit about an hour. Ooh, new erasers. And they work. Or did, singular.
There's not like a mark where you can see where the eraser was. Sometimes when you're erasing, it like leaves a mark and I'm like, oh, that hurts to look at. But that one's
Not yet.
not yet, yes.
All right, so. Just to sort of get our brains functioning a little bit here. I'm gonna do one centripetal motion problem, and then we'll start branching into the next chapter, things that are not on the next test.
It's a roller coaster.
Yeah. Or if you prefer, it's a car in a looped track. It's something that's gonna go upside down. Let's make it 1,000 kilograms. And ooh, better for so let's make this 50 meters. If the car makes it all the way around the track. So obviously, the biggest issue is at some point when it's sort of upside down, if it's going too slowly, it will fall. It becomes a projectile motion problem at that point. If it's going really fast, it's obviously gonna make it around the track, but there is some minimum speed that it will be going so that it will make it all the way around the loop. And so we're gonna concentrate on this spot right here. Oh, sorry, I thought it was unlocked. So what is the speed that has to be that the car needs to be going at the top so that it will not fall?
So we need to know the force,
As in force diagram?
or just like, the total force to find the speed.
Yes. We can do it. So since we're talking about the top there, let's force diagram. We're gonna go through the steps that we've been doing many times. Force diagrams first.
There would be a normal force pushing down on the car and up on the track. There's weight or gravity acting down on the car.
Wait. And then I guess if we throw the ground in there.
We have friction
Where?
on the wheels. wheels of the car?
is
But-
that force negligible?
Let's assume that at that point, we don't need to worry about friction. Besides, friction would be horizontal here, and this is a centripetal issue at the moment.
Okay,
But actually, it would be slowing down until it gets to the top, and then it'll start speeding up right after that. And so that's a point when, if you're going from slowing down to speeding up, you're gonna hit zero in between, so this would be that 0 point. So technically, in our nice ideal world, friction is really, should not be acting at that moment.
okay.
All right, so we're throwing out friction, we got normal, we have a checklist for a reason. Gravitational done, normal done, no other, eliminated friction.
No tension.
All right, so we got that. Direction of acceleration,
To the left.
Is it towards the middle?
it is indeed towards the middle. Did you wanna make a different argument?
No, I'm just trying to think about how that works. I know we've gone over it before, but I just,
The centripetal acceleration, since it's like, I don't know how to explain it, but.
Sorry.
is it because we go full circle where? No.
You could finish, right?
Well, I was thinking that if we go in a full circle, that would, go over the circumference of the circle, but we only have the radius. I mean, like, and not that that would matter as a part of the problem. What I'm saying is like, the acceleration with centripetal force doesn't generally deal with circumference. It deals with radius.
It
Oh.
really depends on what you mean by that.
It's because like a Ferris wheel, you don't get pulled from the other side of the Ferris wheel, you get pulled from the center. You know what I mean? The thing that's holding you to the track is the struts from the center. You're not being pulled
Oh.
from the outside of the thing.
Right, because the car, if the track were not there, the car would then shoot off that way.
Yeah. So it's always towards the thing that's holding it,
Towards the center
Center,
of whatever's
yeah.
holding it, yes.
Think about that problem where the car was on the track and we were looking at it from the back, and assuming it wasn't moving like up or down the track, what was the acceleration? And it was towards the middle.
Okay.
I mean, that's the essence of it, any type of, especially on this test, you got circular motion, the acceleration is gonna be towards the center.
Okay.
If I had it speeding up or slowing down at that moment, then we would also have the tangential acceleration, as sort of mentioned last time. And it would also bring in friction at that point for something traveling parallel to the track. Or a force parallel to the track. But the acceleration is indeed towards the center. And again, as far as force diagrams go, this is not part of the force diagram, this is just a note off to the side. Please do not put acceleration in the force diagram unless you just need to make a note. However, on the complex force diagram problem that will be on the next test, I will tell you the direction of acceleration. You do not need to do that. Besides, you're just doing the forces. Do not put this into that problem. All right, so, well, that pretty much sets up our coordinate system right there. I'm gonna make that the positive direction. There are no forces perpendicular to that, so I don't need another dimension. All right, so equations of, decomposition. Do I need to break anything up? All right, equation.
Y plus W equals M times A, C.
And then is mass gonna be 1,000?
It will be. It actually is irrelevant, but it would be 1,000. Substitution. For what do we have additional formulas?
Why? Y is equal to mg, isn't it?
No. You said why?
Yeah, y, normal force.
You mean,
No, there's not a formula for normal force.
it
That's-
just is.
It's problem specific.
In the case of something resting on the ground, it's mg, because it's the weight of the thing plus gravity pulling it down onto the ground. But in this case, we're pushing up against something,
Okay,
so it's not gravity.
okay.
Yeah, so, in our force diagram, is there a reason why the car is upside down?
It's doing a loop on a track.
Okay, so it's on like the top of the wheel?
Yes, yes.
Okay.
That's the part of the problem. It's basically doing this maneuver right here. And we're trying to find that minimum speed so it doesn't basically go crashing through the air. So we're looking at it basically at the top. That's the critical point.
Okay, I was just
Where
making
it's
sure.
circled. I said where it's circled.
Yeah, yes.
We have a formula for centripetal acceleration.
Okay, what is that?
It is,
V squared over
Yeah.
r.
Why would you use v squared over r instead of omega squared times r? Because we have two formulas. I mean, they're equal to each other. Centripetal acceleration is v squared over r, which is equal to omega squared times r.
I suppose because omega is more supposed to be like a constant.
yeah, we don't have
Motion.
angular speed here.
Not necessarily. Not the main reason.
It would,
Why complicate it?
yeah, take more steps.
What am I asking you to find?
I don't know yet.
With this equation of motion,
Speed.
Yes, I'm asking you to find speed. So the speed version is probably the more appropriate one. If I ask what's the angular speed at the top, then yeah, use this one. All right, what's the other, somebody I think said it, but
The wrong thing, it was W is mg.
yes. All right, so we're in this situation now where I'm trying to find V, except I know M, I know R. Let's pretend it's Earth. I don't know V and I don't know Y, but I have only one equation. How do we resolve that? Two unknowns, one equation.